Welcome to this class. This session, we are going to do examples on how to differentiate by first principle. So there are 4 problems. The first one is to find f prime of x over x minus 1, and then evaluate the value at 3 as specified in the equation. So f of x is x over x minus 1. This is already given. And then we need to define f of x plus h. So where there's x, we put x plus h. Now, by definition, f prime of x is given by limit as h approaches 0, f of x plus h minus f of x divided by h. This from definition. So we'll have f prime of x equals to limit as h approaches 0, x plus h, x plus h minus 1 minus x over x minus 1 divided by h. That's just by replacing in the values of f of x plus h and f of x. So the numerator, we have x plus h over x plus h minus 1 minus x over x minus 1. So let's put this under 1xm. So we have x plus h minus 1, x minus 1. So we'll have x plus h times x minus 1 minus x into x plus h minus 1. Then opening the brackets, we'll have x squared minus x plus hx minus h minus x squared minus xh plus x. And then we don't have to open this. Let's see, some terms will cancel out. X squared minus x squared minus x plus x minus xh plus xh. So just have minus h. So which means numerator over denominator will be minus h over x plus h minus 1 multiplied by x minus 1 divided by h. So this all this is what I've called the numerator, and this is what I'm calling the denominator. So this is the same as minus h over x plus h minus 1 x minus 1 times the reciprocal of this, and this will give us negative 1 over x plus h minus 1 into x minus 1, because h and h have cancelled out. So which means that the derivative will be limit as h approaches 0 of negative 1 over x plus h minus 1 x minus 1. Now we use direct substitution to find this limit, where the h we put 0. So f prime of x will be minus 1 over x plus 0 minus 1, x minus 1, which will be negative 1 over x minus 1, x minus 1, which is minus 1 over x minus 1 squared. Now, they also wanted us to find the value of derivative at 3. So this implies f prime of 3 is negative 1 over 3 minus 1 squared. It will be negative 1 over 2 squared is negative 1 over 4. And then part B, f of x is given by square root of x. So f of x solution is root x. This already given. We need f of x plus h to be square root of x plus h. And then derivative is limit as h approaches 0 of f of x plus h minus f of x divided by h. This from definition. Now we'll have the derivative is limit as h approaches 0. This will be replaced by square root of x plus h minus square root of x divided by h. Now we use rationalization of the numerator to simplify this expression. So we'll have f prime of x equals to limit as h approaches 0. Then I'll have x plus h minus root x. Conjugate of this is root x plus h plus root x. And then h conjugate is x plus h, and then plus root x. Now you see this numerator is just a difference of 2 squares. So its simplification is the same as, so I have f prime of x is limit h approaching 0 of x plus h minus x divided by h. You don't have to open this, square root of x plus h plus square root of x. What I've used here is to use the fact that a minus b, a plus b is given by a squared minus b squared. So my a is root x plus h. So I square it. That's why I have x plus h. And then minus b is root x. I square it, I get x. So that's why I have this numerator. So this implies f prime of x will be equals to limit as h approaches 0. Now x and minus x cancels out, so we have h over h into root x plus h plus root x. And then h and h cancels out. H. So that f prime of x will be limit as h approaches 0, 1 over square root of x plus h plus square root of x. Now direct substitution now works. So where is h put 0, 1 over square root of x plus 0, plus square root of x, which is 1 over x plus 0 is x. So this will be 1 over 2 root x. So f prime at 3 will be 1 over 2 root 3, which can be simplified by multiply by root 3 over root 3. So root 3 over 3 at 2 times root 9, which is the same as root 3 over 2 times 3. So root 3 over 6. And then C, we have f of x is given by x squared minus 8x. So f of x is x squared minus 8x. So this is given in the equation. F of x plus h will be x plus h squared minus 8 into x plus h. So I have x squared plus 2xh plus h squared minus 8x minus 8h. So by definition, f prime is given by limit h approaches 0, f of x plus h minus f of x divided by h. So replacing the values, f prime of x will be limit h approaching 0. So I have x squared plus 2xh plus h squared minus 8x minus 8h minus x squared, but then this minus will be plus 8x divided by h. Now x squared and minus x squared cancels, minus 8 plus 8 cancels out. So we remain with f prime of x equals to limit as h approaches 0, 2xh plus h squared minus 8h divided by h. And because in the numerator every term has a h, we'll factor it out. So limit as h approaches 0, h into 2x plus h minus 8 divided by h. Now h and h cancels out. So I'll have f prime of x equals to limit h approaching 0, 2x plus h minus 8. Now direct substitution will give us f prime of x is 2x plus 0 minus 8, which is be 2x minus 8. Now the value of the derivative at 3 will be given by 2 times 3 minus 8, which is 6 minus 8, which is minus 2. And lastly, D, we have f of x equals to 1 over x. So solution, you start by saying f of x is 1 over x, this given in the equation. And then f of x plus h will be 1 over x plus h. And then f prime of x is given by limit as h approaches 0, f of x plus h minus f of x over h. This by definition of a derivative. Now replace the values. So we'll have f prime of x equals to 1 over x plus h minus 1 over x divided by h, limit as h approaches 0. So let's call this numerator n, this is denominator. So numerator simplification, we have x plus h minus 1 over x. LCM is x into x plus h. So this will be x minus 1 into x plus h, which will be x minus h over x into x plus h. You don't have to simplify or open the bracket in the denominator. By that, we say this x and minus x cancels out. So numerator over denominator will be negative h over x into x plus h. And are then divided by h, which is the same as minus h over x into x plus h times the reciprocal. And this h and h cancels out. So numerator over denominator is negative 1 over x into x plus h. So this implies that f prime of x will be limit as h approaches 0 of negative 1 over x into x plus h. Now you do direct substitution, so you'll have negative 1 over x into x plus 0. So this would be negative 1 over x times x. Now this is negative 1 over x squared. And so the derivative of this function is minus 1 over x squared. So which means the value of the derivative at x equals to 3 will be simply given by negative 1 over 3 squared, which is negative 1 over 9. So that is how we solve those 4 problems. Thank you.